Well, welcome back. In the last recording, we talked about simple random sampling. And we said that conceptually, and even technically, it's about the most valid. Because when you look at the theory underpinning sampling, that theory, primarily, fundamentally actually applies to the simple random sampling. But there were a number of limitations, a number of constraints, especially when it comes to implementation, that one can easily run into. But we're thinking of actually implementing a simple random sampling approach. One of those is that, for instance, think about our watch survey in Malawi. It turns out that even though we know the communities where these interventions actually occurred, nobody actually has the actual list of all the households in this community. So the choice we had at the beginning of that survey is either to first deploy all the field workers to go and have a complete count of all the houses in the communities before we go and decide, before we go and select our sample and then go back to go and find our samples. But then you have to think about the amount of resources we would deploy in actually generating our sampling frame. And guess what? What did we do? Rather than do that, what we did is to tell our enumerators to just start from a point in the community and start moving on. So rather than going around and start assigning numbers to each of the houses so that we would assign numbers to about 10,000 houses, what we just did is that, well, we know that there are about 10,000 houses in our catchment area. So why don't we just decide to, tell each enumerator, start from one place. When you start from this place, we know that we just want to select 1,000, we just want to collect information on 1,000 households. But there are over 10,000 households here. So if we are going to collect 1,000 households, we know that we want to select one household out of 10 households. So we tell each enumerator, why don't you start from here? And then if you collect information from one house, you count 10 houses. The 10th house, every 10th house, select every 10th house and collect data from each of the 10 houses. And what that does is that it saves us the time and the resources that would have needed to first go around the community and assign numbers or assign identity to each of the houses before we select a simple random sample and then go around the whole community again. In essence, what I have just described to us, what we did in the watch survey is to do what we call a systematic sampling, which is that rather than enumerate everybody and then select a sample where everybody has a probability, select a sample, a random sample, a simple random sample, what we do is randomly decide where to start from and then select units at specific intervals. Now, one might argue that then the households that would form your sample would depend on where you start from. Yes, that is true. And that is why it is very important to ensure that that starting point is randomly determined. So essentially, because we knew that there were 10,000 houses in our target population, and we wanted to select just 1,000 houses for our sample, we know that every 10th house would be appropriate. We would need to collect information on every 10th house. So we didn't need to generate a comprehensive sampling frame and do a sample before we started. We just needed to randomly, determine where to start from, and from there we selected the every 10th house to collect information from.